So hello everyone. My name is Hadi Khatib. I'm going to be presenting the work related to the Syrian Archive as well, and how we are collaborating with Adam Harvey from VFRAME. So very quickly, going through the Syrian Archive, it's an organization that started working in Berlin in 2014. And the mission of the organization is to collect, verify, and analyze visual documentation of human rights violations related by all sides in the Syrian conflict. This mission starts with the goal that we want to make sure that this visual documentation is used for any type of supporting legal processes. Like, for example, if any legal process that's going to start where they need, for example, different type of evidence, like witness testimonies and so on and so forth, can we use video to support that legal process? So this is one of the main things. The second thing is, can we use it for advocacy research? How can we support international organizations and civil society organizations to use this type of documentation for advocacy research? And the third thing is related to transitional justice, is how can we use this type of materials to advance transitional justice? How can we reconstruct what has been destroyed from 2011 until now by using these type of materials? So those are the three things that our goal we're hoping to achieve. So since 2014 until now, we haven't been working alone on this. We have been working with many different organizations. So since 2014, the UN Commission of Inquiry related to the Syrian Arabic Republic, it's something that we have been collaborating with on a weekly basis. The European Center for Constitution and Human Rights, we have been also working with them, organization based in Berlin, where we are trying to explore the use of this visual documentation for legal purposes. Of course, international organizations such as Human Rights Watch and Amnesty International, as well as universities like Berkeley University, Essex, Toronto, Hong Kong, and many other universities where students are helping us verify and go through the materials. Investigations teams such as Bellingcat, verification platforms such as Medan and others, as well as organizations like Witness, helped us a lot in terms of building the infrastructure for this, as well as the methodology. And of course, this work would not have been done without the Syrian journalists and all the human rights defenders and civil society in Syria, that they have been documenting these violations since 2011. So before going into a lot of technical details, just a little bit about the Syrian context, why we started these organizations, and what are the problems that we wanted to tackle. First thing, since 2011, and even before, it was really hard to access the country, to kind of report on what's happening in the country. That's because of many reasons. The main reason is the Syrian government would ban the UN, international human rights organizations, as well as international journalists to come and report about what's happening. Of course, not everyone is banned, but most of the people who asked for coming to Syria were restricted. Of course, the security situation would not allow anyone easily to go back to governmental control area in Syria or non-governmental control area in Syria to report on what's happening. So the security situation is also kind of a main issue also for not being able to do that. So with this, and also with what's happening in Syria at that time, technical infrastructure was good, mobile infrastructure was good, internet also infrastructure was good. So this allowed for people who were witnessing the crimes and what's happening there to capture it and upload it online on the internet, mainly on social media platforms. And the main reason for them to be able to do that, because they really wanted to make sure that everyone is witnessing what's happening in their neighborhoods, in their streets, where journalists are not able to go there and report on what's happening in their own areas. Since then, Syria has been really the most documented conflict in history. We've seen hundreds of thousands of videos that have published on social media platforms. And until now, still about 400 to 500 videos are uploaded on a daily basis. So of course, hidden in that material that has been uploaded online, there is a lot of that we need to undercover, such as human rights violations, our main thing, as well as potential evidence of war crimes. So when we talk about potential evidence of war crimes, it's something that really happened last year. The International Criminal Court has issued the first warrant of arrest against Muhammad Mustafa al-Warfali from Libya. And it was mainly based on visual documentation. It was videos that has been posted by Facebook, as well as YouTube. So what they have done is that they collected this type of documentation and they verified them. And based on that, they issued the first warrant of arrest in history based on visual documentation. It's something that is really important for us as Syrian civil society, because right now we know that some of these materials might be important to be used in this type of justice processes. Of course, not just institutions like the ICC have dealt in this, but also international human rights organizations such as Amnesty International. Their latest thing was about using open source materials to undercover the violations of chemical attacks that happened in Syria in Douma this year. And they have done this through open source materials. Of course, Human Rights Watch also have done something similar where they collected many visual documentation that are posted by different sources in Syria, and this was mainly related to Aleppo in 2016. And this is where we see that many videos from different sources have published documents that shows gas cylinder being used in civilian areas. And it's something that has been used by Human Rights Watch to show what's happening. So this is why this type of material is really important, and it has a lot of usage for advocacy purposes, as we have seen right now with those organizations, as well as for institutions like the ICC and as well as the UN. But while we have been working on this materials, we have identified specific problems that through that, we kind of started thinking and creating the Syrian Archive. And it's mainly related to the content itself. First of all, the content is being lost, and hundreds of thousands of them have been lost. And that's because of many reasons, mainly because the people who are taking them are operating in hostile environments, so their devices is being damaged. Cyber attacks is definitely something that happened from the beginning of the conflict in Syria in 2011. Until now, we see accounts of people who are publishing materials about human rights violations being hacked. And for the people in Syria, the main thing for them to be able to preserve these materials was to upload it online on the internet. So for them, they thought about the internet and social media platform as a way to preserve their content. It was their archive. And they have published hundreds of thousands of those videos on social media platforms such as YouTube, of course, Facebook, Twitter, and so on, and Bamboozer, and so on. Since then, in late 2017, Google started their machine learning way of flagging systematically this content automatically, and then outsourcing that to different groups who were then going through it and then deciding if this content should be online or removed. So we have started to raise awareness about this issue because we were lucky. We were following about 4,000 sources between different social media platforms that have been publishing content. And we noticed that most of the sources, most of the videos from the sources were going offline. They were removed. Whole channels were being removed. One of them called Sham News Agency. It's one of the main Syrian channels that has more about 250,000 videos published since 2011, starting from peaceful protests until it went into a conflict. So all that happened very silently. We didn't know about it as a civil society. We just saw that everything was being removed. And we started to talk to the media and we started to raise awareness. And as I told you, we were lucky. We kind of had evidence to show that this materials was there. We had the metadata of the materials. In most of the cases, we had the files, the video files that we can show and prove that these materials was published on the internet, and it doesn't really show any kind of extremism content. It's a human rights content, and it shows the human rights violations. And it's important for it to be there accessible so others can use it in different purposes, as I have showed you in the beginning. So this year, YouTube has, or Google has published their transparency report showing those number of videos, so more than 8 million videos that has been removed. And if you can see the spike in the beginning, this graph is between October and December 2017, so like when they have started using automation to flag systematically this content. We can see more than 6 million videos has been flagged by the automation, which we think most of it also took with it the human rights content that came out of the Syrian conflict. This is also another statistic that we have done. As I told you, we have been following specific sources. So we have seen that, and in blue is the spike of removed content. So we have seen that our content is being removed between 2011 and 2018, and we can see the spike between 2017 and 2018. So this is where silently content has been removed by Google in relation to, for the purpose of fighting extremism content online. So luckily, I mean, collection and preservation was a main issue for us. This is why we have started from the beginning, and since 2014 until now, we have preserved more than 1,500,000 videos related to human rights violations and other things in the conflict. So we have tried to save much of this content, and we have tried to publish campaigns to make sure that people know this problem and kind of work with us in order to preserve this content. So this is one of the issues that we were tackling, is preservation, because this content is being removed. So the other issue is related to the disinformation and the fake information that has been published about the Syrian conflict from day one until now. So of course, for everyone here, fake news in conflict is something that is not new, but the level of fake content and disinformation that has been seen in Syria, it's something that really big on scale. So it's really important for us to make sure that this published content has more added value by being verified. So I will go through some examples of what is a fake content and how we are usually verifying. So this is, for example, some of the fake content, and fake content is being published definitely by governments, by armed groups, by parties related to armed groups, by many different groups in the Syrian conflict. So this one is published by the Russian Ministry of Defense, and this is where they are saying that how the US military is covering kind of an ISIS operation, and they have been showing videos of that. So we looked at it and we were kind of disappointed. Really, I mean, this is the US covering the ISIS operations, and the whole point of fight against ISIS and the coalition doesn't really make sense with these photos. So we started to look more into it. So this is what has been published. ISIS automobile convoy leaves Abu Kamal for Syrians' Iraqi border. So like leaving them back and forth, getting aid and materials and so on. But when looking into it, we see that it's actually not. It's actually just like a game. It's a video game that is published on YouTube. And we can see here the actual video game, and it's just published on an account called Byte Conveyor Studios.
Because that wheel's gone. I don't think that vehicle's going to move anymore.
And this is something that is really interesting. I mean, why the Russian Ministry of Defense would publish something saying that the US is actually covering ISIS operations using videos of games that is published on YouTube. So this is the level of fake news that we arrived to in Syria, and this is nothing compared to the things that they cover showing human rights violations that are happening in the conflict. And usually they try to kind of undermine all the verified materials by publishing, fake news in this way. So this is how, the level. So you have a little bit of an idea, and then going through one example of how we verify a video. So, for example, this is one of the videos that we collected from Aleppo News Agency. So it's where we see a journalist taking a video of the aircrafts dropping a bomb. So this is very important because who has access to air is mainly the Syrian government as well as the Russian government. So two forces, mainly targeting these type of areas. So usually what we do is we make sure that we have landmarks shown in the video. We go through all the video to put landmarks as the journalist was going and walking. So it's really important to make sure that we know that this is the actual location. As you see, I mean, different buildings as well as we can see children and it might be families. So it's happening in a civilian area, and we have checked that through satellite imagery. So all this would really help us to actually go through Google Earth and make sure that we are actually in the location where the journalist has been reported. So this is where he was standing, and these are the different type of landmarks that we have seen in the video. So this is the level of verification that we usually try to get into. And if we have access and if we have a little bit of resources, we are able to get a new satellite imagery that would show the location after the attack. So then we can see some of the impact that happened after these type of attacks. Usually, when this incident happens, many sources kind of publish videos about this, and some of them, for example, would publish videos of people showing the remnants of the munition that has been used in specific attacks. For example, this one, it shows the same building, so it's in the same location, same landmarks, and it shows the remnants of the munition. And through also open source research, we can identify the remnants of the munition. In this case, it's a cluster munition that is manufactured in Russia, as well as the containers, which is also a Russian manufacturer. It's a cluster bomb. And this is really important because with this, we are able to kind of counter government narratives related to cluster munitions used in Syria, where, for example, the Ministry of Defense or the spokesman, he says that we don't have cluster munitions in Syria and we don't use them in the conflict. At the same time, when he talks about this, Russia Today publishes kind of footage from inside Hmaym Air Base, which is their main air base in Syria, showing the preparation of their aircrafts and showing definitely the containers that we have seen earlier containing cluster munitions. Cluster munitions and incendiary munitions, which is a war crime and crimes against humanity if they use it against civilian areas. So this is the type of way that we usually try to verify this content, and this is the second problem. The third problem is related to while content is published online, it's unsearchable because it's scattered everywhere, and usually it misses the metadata because it's stripped when it's uploaded on social media platforms and different platforms. So what we try to do is we try to reconstruct metadata in those videos again. So we kind of created the metadata schema, where we add specific information related to the incidents and related to the video and related to what we see as objects in the videos, and we try to attach this metadata schema to every video that we see. And I'm going to show you right now a quick video related to an example, the latest example of how we reconstructed metadata again from specific videos. It's a chemical weapons database that we have launched last week, and we constructed all the incidents between 2012 and 2018. I'm going to show you the video, then I'm going to go through more details in a bit. So this database has been published actually last week, and it shows 212 incidents of chemical attacks between 2012 and 2018. So it's taken by 192 sources, been published by those different sources, published materials about it, that has been verified by us through the same way that I have showed you before. And also, we identified 85 unique locations where this chemical attacks has been used. So it's not one incident, two incidents, or three incidents. The thing that we are dealing with is hundreds of incidents, and that's why we need to find a way where we can cope. The other thing that is being shown below is we also identified all the videos that has been removed by social media platforms such as YouTube that shows evidence of chemical weapons, not extremism content or nothing related to propaganda. So all this and how we work, we have developed and published online, so from identification of sources into collection, secure preservation, verification, analysis, and publishing. So all the process is published online for anyone to be seen. And of course, a do no harm ethical framework is kind of embedded with this type of work. And what we mean by that is that when we publish content and when we do investigations and when we connect with people, we need to make sure that we don't put anyone at risk. So this is why we really need to be sure that this material this work is being done, but not exposing anyone when doing it. So everything can be seen on the website as tools and methods. So the technology includes the tools that we use for collecting secure preservation as well as for verification. So it's open source tools, and if anyone would like to have a look and contribute to, that would be really great. And the research methodology has every step that we take in order to work on this stuff. So this is not the end of the challenges. There are so many other challenges, but the main one is related to scale. So as I have told you, us as a Syrian civil society organizations, of course, as any other civil society organization, any part of the world, time constraints and limited resources is something that we live with on a daily basis. So the scale of the material is quite huge, and we are not able to deal with, and we can't spend the same resources that others do, where we can spend a lot of resources on one incident and create a great thing out of it. So we really need to acknowledge every incident. It's really important for justice processes, as well as for memory, as well as for transitional justice, even though that we know we are not going to have any possibility to prosecute every war criminal. And this is a big challenge for us. I have started talking to about many people until I arrived to this man here, Adam Harvey. We talked a little bit about it in Montenegro, where we met in a tactical technology collective camp, where many investigators were there. And I think Adam will be talking a little bit more about how he is tackling this issue right now.
As Hadi mentioned, we met about a year ago, and Hadi introduced this problem during an open discussion. People were working on different challenging data projects with the direct challenge of trying to identify objects of interest in a large set of videos, specifically looking for cluster munitions. So I nearly ran over to your table and thought, this is the perfect use case for computer vision. And since then, we've been working on prototypes and discussing ways that we could use machine learning, computer vision, and AI to bolster the limited resources of the Syrian Archive. And the idea with VFRAME is not only that it's directed at Syrian Archive, but that it becomes a computer vision toolkit for sorting through large amounts of information. Such as Hadi described, the simplified version of the workflow would look something like this, where you have a massive amount of videos being pulled from researchers, and some of those are important, but most of them don't contain the object of interest that you need for an investigation. So it's the role of the Syrian Archive to do what I think is a very generous task of sorting through that massive amount of information right now manually, and to bring those resources to the front of the website that are important, to give you access to the videos that are important to understand what's happening in the Syrian conflict. So at the end of this process, then you get the video on the website. As Hadi mentioned, there's really an astonishing number of videos. If you, I recommend going and looking at what's on the site right now, even watching about a dozen videos, maybe as much as you can handle in one sitting. And there are about 1.5 million videos in the database, and they've verified 4.4 thousand of those. Identified 18 different types of weapons, unlawful attacks, violations against specifically protected persons and objects, violations of children's rights, sieges and violations of economic, social, and cultural rights, arbitrary, forcible displacement. Thinking about everything that Syrian Archive does, where does computer vision fit into this picture? And when we have discussions, we're thinking about it not in any way as a replacement for the work that the researchers are doing, but more as a way to accelerate their expert knowledge, to give them capabilities of offloading some of that expert knowledge, of training a neural network with their knowledge, and then putting it to task on this giant database of videos. So we came up with kind of an outline for what this project would look like as it applies to Syrian Archive, where the 5 tasks that VFRAME would accomplish would be locate objects of interest, for example, a cluster munition, extract visual metadata, for example, what is the scene? Is it a parking lot? Is it rubble? Are there ambulances? And provide that as an API. Query related media, so if you do have an image of one cluster munition, can you find more? If you have one image to start investigation, can you find others based on that? And something that Hadi didn't mention too much is looking at these videos can be a very traumatic experience. And looking at too many of them in one sitting, you really can't push yourself too far. So we're thinking about ways to automatically filter the content by looking for, training it on specific types of objects or scenes that can cause trauma. And we put together this proposal, and thankfully we've received some funding, and we'll gladly thank Prototype Fund for supporting the first round of development for VFRAME. So let's get into what this project is about technically. Object detection. In terms of the cluster munitions that are listed on the Syrian Archive website, there are 18. Again, it's another massive task sorting through and learning about all these different weapons. What exactly does a cluster munition entail? What exactly is a barrel bomb? What does it look like? What types of videos does it appear in? Are there many different kinds of it? So the first step in training these computer vision algorithms is to train my own neural network, to train myself to become an expert in identifying weapons. And that involves compiling a report about one specific item in that list. So the first object that we're detecting is an AO 2.5 RT, which is a cluster munition. It looks like that. And this may seem like an easy item to find in a large amount of videos. But when you read into the description, you can see that sometimes it splits in half. It is cast, it has a silver metal cast appearance. It's released from an RBK 500 or a BKF cassette. An RBK contains about 108, 12 submunitions with 96 bomblets, and often when it hits, if it doesn't explode outright, it'll separate in half. So when from the initial photo, the visual profile of an AO 2.5 appears simple, but in the real world it's much messier. It appears with dirt, and so it's kind of occluded. Sometimes it's split in half and with dirt, and the two halves appear differently. The objects can have been sitting out in the weather, and so they're rusted, and now the coloring has changed. The lighting is going to change, and sometimes The only thing left is the arming veins. So in reality, the task of detecting one object from that list of 18 becomes a little bit more complicated. And sometimes it appears upside down and sometimes hollowed out. So really we have a quite hierarchical structure to the way that an AO 2.5 could appear. And there is no existing data set for cluster munition if you're training a computer vision network. When you go online to look up existing image sets, you run into a knowledge gap. And that's illustrated if you go to the Google Knowledge Graph and you do a search for AO 2.5, there's nothing. And it's an empty list. So the next step in VFRAME is that we're constructing a visual knowledge relationship. Instead of thinking about it semantically, which is how most data sets are constructed by using a word graph, we're building out the visual knowledge graph purely between the visual relationships. So if a AO 2.5 separates, those parts that are separated are part of the parent item. And if we zoom in on that, we can see now what all those different profiles are that I described, where we have the arming veins only. The cassette, which I didn't mention, is what the cluster munitions are dispersed in, and so that can be a sign that the video may contain cluster munitions. Now we have a much deeper profile of what that cluster munition will appear as in the data set. And this is a task about reducing information, about taking, as the Syrian Archive does, a massive amount of information and reducing it to the point where it becomes more accessible. If you take one video and watch one video, it's quite, you can end up spending a lot of time. 4 minutes and 16 seconds to watch this video. And one of the first steps that I've taken in developing this project is to develop a way to take that video and condense it, and to produce a dense summary for the manual reviewer. And that means you can take a video that's about 4 minutes and 15 seconds, and you can skim through all the frames in 5 to 10 seconds. So let's see what that looks like with a couple examples. The actual computation time is about 10 seconds on a CPU and GPU. So if you look at the dense summary, which is limited to 12 frames, you can quickly determine that this video should be prioritized. It contains cluster munitions. This video also. And you can do that very quickly with the human perceptual system. So we can save a lot of time. Manual reviewers can save a lot of time by looking at the summary first to get an idea if they should prioritize or invest more time into reviewing that video. I calculated how much time could that end up being. It's about 51 times faster. So it would have taken 8.5 minutes almost to look at those videos, and it takes 10 seconds to look at all of the dense summaries. There's another part of it that's helpful, which is if you see something, you can quickly avert your vision and keep it in your peripheral vision if it contains graphic content. So the idea here, what this looks like, is that we're taking 1.5 million videos, roughly, and we'll produce summaries of them. Even though it only takes 10 seconds, it's such a massive amount of information that it would take half a year on a single workstation to process that. So we can accelerate it to a point, and then we're looking at ways to apply it in other areas. So once we have a video kind of summarized into the keyframes, then it becomes quicker to do object detection. So then we can run a finer-grained computer vision algorithm on those summarized keyframes, and that means once we have those, we can analyze a video in a fraction of a second to determine if it has cluster munitions, determine if there's an ambulance, and any other objects of interest. To build the object detection algorithms, the most important step is creating a data set that shows all of the different ways that object can appear. Stepping back from the technical details to think about what a data set is, the data set kind of is the algorithm. This quote from Geoffrey Hinton, in one of the originators of artificial intelligence, describes it as our relationship to computers has changed. Instead of programming them, we now show them and they figure it out. The data set is the code that goes into training a computer vision model. In order to facilitate creating a large data set, I've created another tool called VCAT, which is a way of importing images and annotating them, assigning them to other people. There are quite a few existing ways of doing this, and I've reviewed several of them. Some of them use the full video, so you tag every frame of a video. Other ones, you upload it to a crowdsource site. And we don't want to do crowdsourcing with the graphic content, so we're keeping this limited to our team and the network of researchers that work with it. I'll show you a video of how this works. Let me go back one. You can see here how it works for a truck. So you start with one photo. Now if you want to build a data set for an ambulance, then you can quickly search. Right now it's 138,000 images, which is about 10,000 videos. And you can quickly select all of these. Let me try one more time on this video. Okay. In this example, it starts with an AO 2.5, and you can see the results aren't that good because it contains a lot of scene information. So we can zoom in and crop a region, and then we can search the database based on that crop, select images. So here we're using the human perceptual system to quickly scan the page of similar results to that image. Now begin selecting images that we can see have that item in it. And then search again based on those new ones. And this becomes quite a powerful way to quickly build an image data set. Now we have roughly 30 or 40 images, and we can keep searching that. The data set here, the searching data set, has only 10,000 videos, as I mentioned. So when we get up to 100,000, it's likely that we'll be able to build a data set for an object of interest that the Syrian Archive would need to do an investigation in a matter of minutes. Okay, so these are the arming veins. And now that we have our selections, you can go to review them. I'll skip ahead a little bit. And I'll point out one other feature that was built into it is a panic button. Occasionally, you'll do a search for something and you'll get results that you weren't expecting. With graphic contents, you can quickly clear the search results and start over. Okay, so then you have a saved data set, and you can review it and deselect items that were erroneously tagged. And another feature is that it will check for duplicates. So if somebody else using the system has already imported that image, then it will prevent you from reduplicating that into the data set. And I showed this with the truck. So the next step is a lot of work because it involves drawing a lot of boxes on the objects. But if you like drawing boxes, we are looking for annotators. So this involves identifying the object, and you can see the menu is pre-populated with the visual knowledge graph that I showed earlier. And we want to really accurately draw that box exactly around the perimeter of that object as you would expect it to be detected by the object detection system. And we can keep going, and here's a split inner with arming veins. And at the end of that, you end up with this beautiful set of annotated images where each of the regions can be extracted and pulled down locally and then fed directly into the training workflow. Currently, we have, compared to a lot of the existing image data sets, this is a lot of room to grow. We have 975 annotations so far relating to cluster munitions with 317 images imported into the system. Now, using this data, I've trained an updated object detection model for cluster munitions, and these are some of the outputs of what that looks like. So you can see in this example, I identified the one on the right correctly. That's a split inner with arming veins. On the left, it was about 80% accurate. This is a split inner without arming veins. Sometimes it does miss it. And so this is evidence that more data is needed to generalize to different appearances of this object. We can see in this one where the algorithm is failing. It failed to identify the one on the right. It successfully identified the arming veins in the middle. And you can understand maybe why, because the arming veins have a lot of unique information. It's a real signature appearance compared to the background, whereas the upside down, the outer shell could appear very similar to a rock. When we're getting above 90% accuracy on the correct identification, here is split inner with no arming veins. This is going to be, I think, extremely helpful in parsing the database that Syrian Archive has created and prioritizing the information to manual reviewers. In this case, it works very well because, as I showed in the beginning, this is kind of an ideal appearance, the original state of the cluster munition. But in many cases, it's been bent or covered in dirt, and it's much more difficult to detect. As I've been working on this project, it's been impossible to not think of it as a surveillance tool. But this is, I think, a short-sighted way of looking at how these tools can be used. Surveillance is a way of extracting information in a one-sided relationship. And here we have people that want to share information, people that want to tell you something, people that are holding cluster munitions up to the camera and screaming. And there are so many of these videos that there's no way to look at them all. So one of the ways of rethinking these tools is as providing a kind of visual information protocol for exchanging visual information in large quantities. If a lot of people have evidence of war crimes, of cluster munitions, and they push them through video channels, are there people or are there ways to understand all of that information? And that's what VFRAME and our collaboration is trying to accomplish. The most recent model that's currently being trained, I can show a quick demo of this. So there are some situations where it works very well. And for the objects that are incorrectly tagged, well, what we're trying to do is create this hierarchical visual model of the way something appears. So if it has arming veins or if it does not, then we can still go one step back up the visual knowledge tree to the actual object. And that's what we want to detect. So the framework that we're using, more on the technical side, is called Darknet, and it has a great name called YOLO, the actual implementation of it. And this hierarchical model is called YOLO 9000, which is another great name. Then the current status of the project, what we're working on this month, is to build out this data set of cluster munitions to try and achieve about 1,000 annotations per view of an object. Add the other ones that I didn't mention, SHOAB, SPBED, PTAB, 1M, BTAB, and ZAB. Analyze maybe 10 to 25% of the database using the video summarization method and try to push all this information through the object detection framework and create the next demo, which we'll present in June. And then the next step will be to add more items to the visual knowledge tree, to expand beyond cluster munitions and look at ways that indirect objects, such as a helicopter, could be used to infer barrel bombs, and to really expand that. And to explore providing some kind of graphic filtering, which will be a real challenge, and then to take this information that can be extracted from the video and turn it into basically a web API that can integrate with the Syrian Archive's website and with their database. This project wouldn't be possible without funding, so thank you again to Prototype Fund. And we'll also extend a thanks to the next organization that would like to support these projects or has any helpful recommendations about where to submit applications. Thank you very much.
So are there any questions, perhaps? Please raise your hand and I will come to you right now. Oh yeah, in the first row.
Hey, thank you. Thank you for the presentation, of course. I have a question about funding. In the future, do you have any restrictions on who you would accept funding from?
So as the Syrian Archive, we don't accept funding from governments that are directly involved in the Syrian conflict. This is one of the exceptions that definitely is going to affect politically the project and also expose a lot of the people who are working on it. So this is one of the things, definitely.
Yeah, as for VFRAME, definitely want to steer clear of any funding that can cause political conflict for the project. Right now, we're thinking about ways to apply collaboratively more along the lines of investigative journalism, but of course we do scrutinize where the money comes from.